Now let us do question number 5 in exercise 7.1. Read the question, take your content book page number 161, read the question. What is it? In a classroom, 4 friends are seated at the point A, B, C and D as shown in the figure. Which figure here? This Cartesian plane with these checked boxes is nothing than your classroom. And in the classroom, the children are seated in 4 different places. All those 4 children are friends. Find out their coordinates, their position. For A, what is the position? In x-axis it is 3 and in y-axis it is 4, 3, 4. For B, what is the position? In x-axis, this is your x-axis, right? The horizontal line is your x-axis. In x-axis, B is 6 and in y-axis, B is 7. Come to C. In C, in x-axis, the value of C is 9 and in y-axis, the value of C is 4. So, we found out the vertices of these points first. And for D, what did it sit? 6, 1. Okay, fine. These are 4 friends are seated as it is given in this diagram. Champa and Chamili walk into the class. 2 children, maybe the children belong to the same class, are there from the next class. When they walk into the class and after observing for a few minutes, the first person, Champa, asked Chamili, don't you think ABCD is a square? After seeing that, simply if somebody is sitting and if we observe something, for example the clouds in the sky, we'll be feeling like sometimes it looks like a duck, sometimes it looks like an elephant or an airplane. It depends upon our imagination, right? Like that, Champa is asking to Chamili, by seeing the seating arrangements of these 4 friends in this particular class, it looks like a square, isn't it? Champa is asking Chamili, don't you think that ABCD is a square? Chamili disagree. Don't you think ABCD is a square? Chamili is not agreeing to it. Using distance formula, find which of them is correct. Now we are going to use the distance formula. How many times are we going to use distance formula here for this particular sum? 4 times. We need to find out the distance of EAB, then we need to find out the distance of EAD, and then we need to find out the distance of CD, and by final we need to find out the distance of CB. When children, we can say that some closed 2D quadrilateral is a square, when we can say that a closed 2D quadrilateral is a square, when if you find that all the sides of that particular quadrilateral is equal, if only all the 4 sides are equal, we can say that, can we say that it is a square? No. Even for rhombus, all the 4 sides are equal. So what is the difference between rhombus and square then? With respect to the distance of sides or diagonals, the only difference for the square and the rhombus with respect to distance is the diagonals of squares are equal, but the diagonals of rhombus are not equal. So what are we going to do in this sum? In this sum, we are going to find out all the 4 distance of AB, BC and CD. And then what are we going to do? We are finding out the distance of the diagonals, AC and BD. If the diagonals are also equal, it is a square. If not, it is not a square. So we are going to find out whether Champa is correct or Chamili is correct. So in this question, I took the 4 points. I found out the vertices of the 4 points. I started with finding the distance between A and B. Do you know the formula for distance of 2 coordinates? That is root x2 minus x1 the whole square. So 6 minus 3 the whole square plus y2 minus y1 the whole square. 7 minus 4 the whole square. 6 minus 3 square becomes 3 square. 7 minus 4 whole square becomes 3 square. 3 square is 9. If I'm adding, I'm getting root 18. If I simplify, I'm getting 3 root 2. The same way, I'm going to find out the distance between BC, CD and AD. Every time when I'm finding the distance between any 2 particular vertices, I wrote what is that vertices. For D, the vertices is 6, 1, and for A, the vertices is 3, 4. I wrote the vertices first, and then I found out what is x1, y1 and what is x2, y2. After what I'm doing, I'm substituting in the formula. What is the distance formula? x2 minus x1, that is 3 minus 6 the whole square plus 4 minus 1 the whole square. When I'm simplifying, for DA, I got 3 root 2. For CD also I got 3 root 2. For BC also I got 3 root 2. And for AB also I got 3 root 2. What does it mean? The 2D closed quadrilateral may be either a square or a rhombus. Now I'm going to find out whether it is a square or a rhombus. How I will find out that? I need to find out the distance of the diagonals. Diagonals is AC and BD. The same I'm doing here. See the diagonals. AC is the point of A, that is 3, 4, and the point of C, that is 9, 4. After writing the points, what do we want to do? We need to find out what is x1, y1 and what is x2, y2. After that, AC is equal to, substituting the formula, x2 minus x1 the whole square plus y2 minus y1 the whole square is substituted. 9 minus 3 is 6 square, 4 minus 4 is 0, 6 square is 36, and square root of 36 is 6. So what is the distance of the distance of the diagonal here is the length of the diagonal. So what is the length of the diagonal here, AC, which is 6. And then come to B and D. The coordinates of B is 6, 7 and coordinates of D is 6, 1. Again x1, y1, x2, y2. BD is equal to square root of 6 minus 6, which becomes 0, and 1 minus 7. 1 minus 7 becomes minus 6. Minus 6 the whole square becomes 36. And 36 plus 0 becomes 36. Square root of 36 is 6. So what is the distance of the diagonal BD? The length of the diagonal BD is also 6. The length of the diagonal AC is also 6. The length of the diagonal BD is also 6. What does it mean? Therefore, the 4 points are square. So, who is correct here? Champa is correct. How we found out whether the given 4 coordinates are square or not? Simply by finding the distance. The distance of each point gives the length of the side of the quadrilateral. All the 4 sides length of the quadrilateral is equal. So, we came to a conclusion that it may be either a square or a rhombus. Then we calculated the diagonals and then we concluded that it is a square. How we said it is a square? Because the length of the diagonals are equal, therefore it is a square. Here are few conditions for 2D shapes. What are the conditions? If you have 3 vertices, if you find the distance between all the 3 vertices, if all the 3 sides are equal, then it is an equilateral triangle. If 2 sides are equal, then it is isosceles triangle. When 3 vertices are provided with you, and if you want to find out whether it is equilateral or isosceles, what you will be doing? You will be finding the distance. If all the distance are equal, it is equilateral. If any 2 sides are equal, then it is isosceles. When 4 vertices are given to you or posted to you in the question, what will you do? You will be checking the length of all the 4 sides. When 2 sides are equal, when the 2 opposite sides are equal, it may be a parallelogram also, maybe a rectangle also. If the opposite sides are equal and the diagonals are equal, it is a rectangle. If diagonals are not equal, it is parallelogram. When if all the 4 sides are equal, then it may be either a rhombus or a square. If all the 4 sides are equal and diagonals is not equal, it is a rhombus. If all 4 sides are equal and diagonals are also equal, then it is a square. Like last sum. The seating arrangement in the classroom is a square. In parallelogram, rectangle, square and rhombus, in everything, the diagonals bisect each other. Diagonals are not equal for parallelogram and rhombus. But the diagonals is an important point, don't get confused. Diagonals are not equal in parallelogram and rhombus, but in all the 4 2D shapes, diagonals bisect each other. So with the help of the conditions which we have learned, let us see what is question number 7. We are going to solve question number 7. In question number 6, the remaining 2 subdivisions are homework for you. Find the point on the x-axis. You are going to find a point on the x-axis. Children, do you know how a point on x-axis will look like? It should be written as x, 0. The coordinates of a point on x-axis can be written as x, 0. We are going to find out such a point which is equidistant from 2, minus 5 and minus 2, 9, which is equidistant from 2, minus 5 and minus 2, 9. They gave a condition 2. Okay, point on x-axis is x, 0. Therefore, A is x, 0 and there are another 2 points B and C. B is 2 comma minus 5 and C is minus 2 comma 9. The point A must be a point on the x-axis, as well as there is one more condition that the distance between AB is also equal to the distance between AC. AB must be equal to AC. Let it be. Now let us find out the distance of AB. Okay, what is A? X comma 0. What is B? 2 comma minus 5. Here we are going to deal with the coordinate where it has a variable x comma 0. AB is equal to x2 2 minus x1 is x the whole square plus y2. By formula here it is y2 minus 5 plus y1 which is 0 the whole square. How we will write these as? Let us stop with that. We'll go for the next distance AC. A is x comma 0 and C is minus 2 comma 9, x1 comma y1, x2 comma y2. So the total distance AC is equal to square root of minus 2 minus x1 here is x the whole square plus 9 minus 0 the whole square. Now we are going to equate AB and AC. Why are we going to equate simply AB and AC? Because the condition is given that the distance of AB is equal to AC. So we are going to equate. When I am equating, first I am eliminating the square root. How can I eliminate the square root? By squaring both sides eliminated. Then minus 5 whole square becomes 25. Minus square is plus and 5 square is 25. Similarly 9 square becomes 81 here. Now what you have in this term? In this term you have 2 minus x the whole square. Expanded a square plus b square minus 2ab. A square is 2 square. B square is x square minus 2 into x which is 4x. Similarly expand here also. Before expanding here, in both the terms I have minus that I took commonly outside. So my term become 2 plus x and my minus if I square, the square is common for minus also. So when I am square this minus it becomes plus. Minus into minus is plus. Again a plus b the whole square, that is 2 plus x whole square. A square plus b square plus 2ab. Now cancel 4, cancel x square, minus 4x plus 4x. Bring this plus 4x to the other side of your equation, that it becomes minus 4. Minus 4x minus 4x. And 81 minus 25. 81 minus 25 becomes 56. Minus 8x is 56. So what is x minus 7? What are we going to find out in this sum? We are going to find out a point which belongs to x-axis. So it can be written as x comma 0. And that is the condition is also given. You are not supposed to simply find out a point in x-axis as you wish. They gave another 2 points B and C, and the point on the x-axis must be placed equidistant between this B and this C. That we found out using the distance formula. Now let's see your question number 6. Question number 6, you have 3 subdivisions. One I am going to solve for you now, and the remaining 2 is homework. See, 4 vertices are given and you need to find out, if you join all these 4 vertices, what 2D shape you are getting, what 2D quadrilateral you are getting. So 4 quadrilaterals we know, and the conditions for those 4 quadrilaterals also we have learnt here: parallelogram, rectangle, rhombus and square. Now take all the points, name all the points as A, B, C, D. And what are you going to find out now? Now we are going to find the distance between each 2 points. First we are finding AB, then we are finding BC, then we are finding CD. So find it for AB first. Take the 2 points of A and B. After writing the points of A and B, please kindly do mention what is x1, y1, what is x2, y2, because coordinate geometry is an easy chapter, and the formulas in coordinate geometry is also very easy. You can memorize it and you can use the formula easily without committing a mistake, and you can substitute the values also fine. Only integer arithmetic operations you are going to execute here in coordinate geometry, but there are chances that people lose mark in this chapter because of the carelessness of the signs as well as changing x1 and x2. So it's my request to you all, when you are finding distance between any 2 points, for example A and B, write the coordinates of A, write the coordinates of B. Do mention what is x1 comma y1 and what is x2 comma y2. If this is done, I'm damn sure No one is going to commit any mistake even in the calculations. Then the formula goes like x2 minus x1 the whole square. x2 is 1. There is a minus in the formula. With that minus 1 it becomes plus 1. So 1 plus 1 whole square plus 0 plus 2 whole square. So it became 1 plus 1 whole square and 0 plus 2 whole square. So you get 2 square plus 2 square. When you take squares, 4 plus 4 root 8, which is equal to 2 root 2. Check the distance between the next two sides, which is BC. B is 1 comma 0, C is minus 1 comma 2, x1 comma y1, x2 comma y2. Find out the distance, substitute the values, square, add, and find the square root. Then we are going for C and D as usual. Write the coordinates of C, write the coordinates of D, mention what is x1, y1, what is x2, y2. Substitute in the formula. X2 is minus 3, there is a minus in the formula. Minus of minus 1 becomes plus 1 whole square plus y2 is 0 minus y1 is 2 the whole square. So you get 2 square plus minus 2 square, which is equal to root 4 plus 4, which is equal to root 8, which is equal to 2 root 2. Then find out the distance of DA. Since 4 vertices are given, 4 sides will be there for the quadrilateral, and all the sides distance, that is the length of the sides, we found out, and everything is 2 root 2. So AB equal to BC equal to DA is equal to CD. Now we want to check the diagonals. So it may be a square or a rhombus. Check the diagonals EAC. Take the values of EA, take the values of C, substitute in the formula, and find out you're getting the distance as 4. Go for BD. For BD also, x1, y1, x2, y2, minus 3, minus 1, 0, minus 0 whole square. That distance is also 4. Therefore, the diagonals are also equal. What does it mean? The given vertices form a square. The given vertices forms a square. 4 vertices are given, so 4 sides distance we found, all are equal, so it may be a square or rhombus. So what we did as the next step, we found out the length of the diagonals. Since the length of the diagonals are also equal, this is a square. Now note down your homeworks. Do examples 1, 2, 3. Exercise 7.1, question number 1, subdivision 1. Do question number 2, question number 4, question number 6, subdivision 2 and 3. That's all the sums you are going to solve by finding the distance between the given points. Thank you, children. Go through the video again. This is again a new concept for you, like AP. You know coordinate geometry. It is all about Cartesian plane, coordinates, the quadrants, how a point looks like in first quadrant, second and third and fourth, where we have negative sign, where we have positive sign, everything. But in 10th standard, this is a new concept. You are going to find out the distance between any two vertices given in the Cartesian plane. At this point of time, I would like to insist an important thing. Since this is Cartesian plane and there are negative axes also, sometimes we will get the distance also as negative. In exercise 7.3, we are going to find out the area of triangles and quadrilaterals. There also we will get area as negative. No, it is not an issue. Just simply neglect the negative sign and take the values. Suppose if you get distance is minus 5, it means that it is 5 units. We don't have any units here as centimeter square or millimeter square or kilometer square. We don't have units for Cartesian plane. Simply we will take it as a 5 units distance. 25 square units is the area. So neglect negative sign if it comes in the final answer as distance or length or area. Thank you, children. Meet you in the next video. See you.